Welcome to Bitgardner's Office Hours. My name is John Kowalski. I'm part of the marketing team here at Bitgardner, and I'll be your moderator for today. If you're unfamiliar with our Office Hours format, we'll have a shortened presentation, usually 20-25 minutes, followed by open discussion. Are there challenges going on in your facilities? What questions do you have, comments? So if you do have any of those questions, please enter them in the chat box, bottom right-hand corner of your screen, and we'll get to them in order. And looking forward to a great short presentation and a lively discussion. Today's presenter is Mr. Andreas.Stummer. He's our business line manager for dispersion and resident expert on dispersion and milling. So with that, Andy, take it away.
Thank you very much, John. Thank you, everybody, for joining us today. Really appreciate it. And like John said at the end of the presentation, if there are any questions, please feel free to ask or chime in and try to get through them all. So here, just a quick introduction about the VMA Getzmann company. So VMA is a German company. They're located about 30 miles east of Cologne, Germany. They've been in business for almost 50 years now. And BIC has had the exclusive distribution rights for the US and Canada since 1988. We used them first in our lab space here in the US. The Dispermats and customers came in and saw them, and they were asking, is it possible to actually buy those units? And that's when BIC made the decision with VMA to actually import them into the US and then sell them through our distribution channels and also then support them as well. So the company, again, was founded by Hermann Getzmann. He's actually a co-founder of Anton Paar. I don't know, some of you might be familiar with that company. They make measurement devices. VMA is still owned by the same family. The company is now run by his two sons, Christian and Martin. They're very active. They have about 70 employees and 6 people exclusively just in the design department. Probably 40% of everything that VMA makes is custom, especially for lab space or even pilot and manufacturing. They come up with a lot of intricate solutions for that space. And they're known to be a high-end manufacturer of dissolvers, speed mills, basket mills, again, for lab space, pilot, and also production. We started to offer production units in North America about 4 years ago, very successfully because of some of the unique solutions that we offer. And there was different presentations on that. If you're interested, we have some on YouTube. We offer them as well on a custom basis. If somebody's interested, we can discuss those. So the company is all over the world pretty much. Most countries, 65 countries where we are present at the moment, every continent pretty much, very innovative, very flexible to customer requirements. And then again, the philosophy is really not only to cover the lab space all the way up to pilot and then production. And then we offer trial on a custom basis up in Wallingford or in Germany at our headquarters for VMA. So just to give you an introduction into the dispersion process, what we're actually trying to do here. You can see that great slide right there, the picture, these larger building blocks, they're called agglomerates. These are basically small particles that are fused together through these, they're called van der Waals forces. These are invisible electromagnetic forces that are basically holding and attracting these particles together, almost like a magnet. And we're trying to break up these binding forces. That's really what we want to do when we are talking about dispersing. And when we use, for example, a house blade or a disperser, and we put in some shear force, we're actually breaking up these binding forces. So with these agglomerates, I actually turned into aggregates. These are the smaller clusters. If we want to go down to the primary particle size, a shear or a cow's blade is no longer sufficient. We really need to do some fine grinding or media milling. So that would allow us then to turn these aggregates into the primary particles. So the idea is in the dispersion process to really wet the surface of our solid particles, the mechanical breakdown of these particles, so these van der Waals forces to break those up, and then stabilize the smaller particles with different types of additives that are on the market. Some of you probably are very familiar with additives from Big USA. They have some really good products that can help you there. So it's really critical to remember that we are not talking about destroying any particles. It's really just about particle size reduction. Agglomerates and aggregates are reduced to primary particles, and really the shear forces are responsible for that separation, nothing else. And then at the end, we want to use the right additives to keep these particles then in a suspended state. So in the dispersion process, we have two different distinct processes. So the first initial part is called the pre-dispersion, where we use the mixer or the dissolver with the Kautz blade. And what is important to remember, we always look at tip speed. We have a lot of customers that ask us about RPMs. While RPMs are important, it's not the only value that we need to look at. It's only part of it. The most important value is actually the tip speed or the peripheral speed. And we're looking to be anywhere between 18 to 25 meters per second of tip speed to optimize our pre-dispersion process. Anything less will just lead us to more time that is needed to break up these particles. Or if we put in too much shear, then we may not be able to also disperse. It's kind of like a diminishing return. So really the sweet spot is 18 to 25 meters per second. When we accomplish that, we're looking at around 20 microns, 10 to 20 microns of particle size is how small you can go in the pre-dispersion process. Really not much smaller. Obviously, that also depends on the type of product that you're running. So not all the pigment classes are the same or different types of materials on the market. But usually 10 to 20 microns. That's where we then need to stop when we reach that point, and that's when we move over to the fine dispersion milling or grinding process. And there, our tip speed or rotor speed, we don't longer use a Kautz blade, we use a rotor or a milling disc. Our tip speed should be anywhere between 10 to 16 meters per second. Some literature actually talk about 9 to 15 meters per second. It's splitting hairs, so anywhere in between that range is ideal to optimize our fine dispersion process. So when we talk about the dissolvers, which is for the pre-dispersion, with the Kautz blade, we have a range of different products. We will cover some of those, all the way from entry level LC30, very small lab scale, and then more advanced like the AE model that has a lot of different capabilities in terms of process monitoring, as well as data storage and so on. We'll talk a little bit about that as well. And then for the fine dispersion process, we have three different types of milling systems. So we talk about the vertical bead mills, which is the milling system APS. APS stands for air pressure system. It's like a vertical bead mill. The second option there would be basket mills. They're very popular for a number of reasons. One of them is ease of use and also ease of cleaning. They have some big advantages. And there we talk about the tourist mill TML or TML tourist mill. That's our basket mill system. And then we have the horizontal bead mills, Dispermet SL, or for production RS5, RS10 for large volumes. That is our solution for that. So what is really critical, the first step when we talk about pre-dispersing, a lot of customers sometimes have questions about what type of blade or what should be my blade ratio to my container ratio. And so here is a good slide that shows you usually about 1/3 of the diameter of my vessel should be my blade diameter, but there is a range depending on the type of product you're running, viscosity and so on. You have the flexibility of either reducing the blade size or diameter or increasing the blade diameter. So over here on the right, you can see the chart. On the bottom, we show you the container size in milliliters. And then on the left, you can see the actual diameter of our dispersion disk in millimeters. So if we would take, for example, a 1,000 milliliter container is about a quart. The sweet spot there is usually start out with about a 50 millimeter diameter blade, should be good, where you can go up or down depending on the viscosity to really dial it in. So that's really important. You don't want to use a blade that's too big or too small, or you're not going to get a proper dispersion effect, and you're also not going to get a donut effect. We're going to talk about that in a second here, which is actually the visual cue, what we are looking for when we actually look inside of the container during the dispersion process, telling us whether we're doing a good job or not. And also important to remember is you don't want to be too low in the container. You always want to have about half an inch to an inch, depending on the container size, obviously, distance from the bottom up to the dissolver blade. The next slide here is really important. It's how you calculate the tip speed. Again, RPMs, different models have different RPM ranges. The larger the unit, usually the lower the RPMs. And the reason for that is that the diameter of our blade is larger for larger units. Therefore, we don't have to use such high RPMs to get to that optimum tip speed of 18 to 25 meters per second. So the tip speed is actually calculated pi times the diameter of my dispersing blade. So if we want to calculate meters per second, we would do that metric. So if my 50 millimeter blade, we would use 0.05 and then multiply that by the RPM and then divide everything by 60. That would give us meters per second, and that would then allow us to precisely calculate it. On the higher end machines, on the AE model with the C technology, we actually display the tape speed on the graphical interface. But that's a good formula to know, and you may want to write that down. So the donut effect, it's really called that because when you optimizing the pre-dispersion process and you're actually looking inside of the container, you should see kind of a donut being formed. And that's what you really want to see. So the actual breakup of the particles happens on the edges of a dispersing blade. And I would actually have added on this slide some more particles on the bottom because you're shearing there as well. So it's not only on top. So the shearing action also happens on top and on the bottom of our dispersing blade. So I didn't personally design this graph, but you can imagine there should be more particles there, and obviously on both sides. So that's what happens when we actually pre-dispersing and we're introducing the shear forces, how our particles or larger clusters respond to the shear force. So here is a good example of a donut. That's what we see when we have an optimal dissolver prep. In this case, we have 21 meters per second of tip speed, and we're putting in about 850 watts of energy. We have really good viscosity. Everything is optimized. That looks great. You can expect to have really good particle size reduction. Usually, depending on the product, anywhere between 10 to 25, 30 minutes is usually how long it takes to deagglomerate these particles with the cow's blade. And then the next step obviously would then be to do milling. In this case, the viscosity is not really high. We don't have a donut, and we're only putting in 320 watts of energy with the same tape speed. So it's not ideal. So in this case, you should really look at the formulation and maybe increase the viscosity somewhat, but you're going to disperse a lot longer because you're not having the energy input that is really desired to really break up these binding forces. So when something is really low in the viscosity range. It's sometimes more difficult to get a donut. If you were, example, like water, you would never see a donut. The donut would immediately collapse and would be very difficult to put in any type of energy. Also, if you have some material that is extremely viscous, sometimes you're also not seeing a proper donut at all. So that's also possible. Okay, so important to remember is in order to optimize our results, the dispersion time, 15 to 30 minutes. Some cases it can be even faster, 10 minutes I've seen. The donut effect, as long as the viscosity is properly dialed in, usually around 2 to 10,000 centipoise, you should see a really beautiful looking donut. Anything less or more, it may be more difficult to get that. Tip speed, again, 18 to 25 meters per second. Geometric consideration, what we talked about, the blade diameter to the vessel, right choice of impeller disc. So there's a number of ones on the market depending on the product that you're running. So you have some choices there. Use the one that works best for your process. The amount of mill base, usually the rule of thumb is about 50% fill rate in your container. You can go up to 70%, but not more. Otherwise, you're going to spill the material, and it's not desired to have product running over the container edge. From a formulation point of view, pigment and filler concentration, very important that you optimize that. Keep the temperature usually as low as possible for most products. In some cases, we have customers for certain applications that actually have to heat it. But when we are dispersing and we're dialing in the parameters and we get to our tape speed at 18 to 25 meters per second, you can see usually that we are introducing a lot of energy, and that will automatically bring up the temperature. So you would want to have a double-walled vessel and possibly some cooling capabilities like a chiller. Some people use tap water that they hook up to really maintain a certain temperature that is good for your product. And then again, use the type of additives that work for your formula, like to improve the wetting, dispersing effect. And then we don't want to have any flocculation once we complete the process, so that these particles actually stay in a suspended state. So that's also very important. And once we achieve all that, then you can move over to the bead milling process, which is then where we go down to the primary particle size. So because it's a short presentation today, we're not going to go into the milling part so much. This is more of an overview of the pre-dispersion process and the actual different types of equipment. So here you see the entry-level model. That is actually a CV3 right there. That's perfect for a small lab, benchtop unit. You can go up to 20,000 RPMs with the blades that you can pick. Very easily will you be able to get to that 80 to 25 meters per second. It's fully modular, allowing you to put on different attachments on the same unit. So you can turn this small disperser into a media mill or a vacuum system or even a rotor stator. There's a ball scraper system that you can purchase for really viscous materials. So it's very versatile. That is kind of the trademark of the VMA Getzmann Dispermat brand, that they have all these modular capability. We also offer explosion-proof units, and then the premium models have the software capability, our C technology, that allows you then to store data in a database or on or on a disk or anywhere where you want to send the data. So we have the capability of making these changes, so we can turn the disperser with the Cal's blade on the fly. I can turn this obviously into a homogenizer, so I can use a propeller tool or butterfly tool that I can put on there. I can use it as with the rotor stator attachment to do emulsification of different materials. Some people also use that for some sort of milling. For certain applications, works well. And then obviously it comes with the dissolver discs to do the dispersing or mixing. And then you also have the capability of adding different milling tools, either For the APS, we add a milling disc, or you can add a basket mill onto the same unit. So a very versatile pieces of equipment. That's a great slide showing you one standard disperser. So this is the flagship model, the AE, with the new control panel, the C technology, and then on the pictures around it, you see these different attachments. So we got the rotor stator on the top left. Bottom left is that APS vertical bead mill system. On the bottom in the middle is our ASC wall scraping unit. Then we have the TML, which is our basket mill, and on top right, we have our vacuum system called the CDS. So they can all be purchased either at the time when you buy the Dispermat or at a later time. They are always available, and that gives you full flexibility to run them for different products. So this is the LC, very inexpensive, pretty standard. I'm not a big fan of it personally because you have to manually lift up the motor up and down with that. You see that lever right there. You turn that to open it, and then allows you to move the motor up and down the shaft manually. So if you want to oscillate, or you frequently have to move the blade, the blade height to a different location, I don't recommend it because you do that manually. It's a pain in the butt. So there is the next model we talked earlier is the CB3 that has that electric capability. This one is relatively inexpensive. We also have the ability to display the speed and also a timing function on the display. But does have the modularity. So that's the CV. That's the next one up. Still an entry model. Electric lift motor, which is nice, comes with different safety features. So we have one is called the working area safety feature, which allows you to set an upper and a lower threshold with that with that slider right here on the side. It actually uses an Allen key to loosen that, and you can slide that up and down to set the upper height limit. And on the back, there is another one for the bottom. And that allows you then to safely operate the disperser when it's running inside of the container. So if somebody were to lift it up while it's running, it would stop or it would automatically shut off, depending on the model. Therefore, you would not have a spinning blade outside of the container. You wouldn't have product flying around the lab and nobody get injured by a spinning disc at 20,000 RPM. Also, this model here will give you the ability to measure temperature, which is great, especially if you want to use it for milling. It also gives you a torque reading, which is a percentage of the motor power that is being used, and it will give you a percentage of torque. Also, timer function and RPM are displayed right here on the control board. Very low maintenance, great machine. If you never worked with the Dispermat, one thing that really stands out is the noise level. They're extremely quiet. We have a lot of customers, especially at the show, they came to us, they said, can you turn it on? We turn them on, they run at 10,000, 15,000 a day. Like, I don't even know it's running. That's how quiet they are. So no comparison to a lot of these other mixers on the market. They're really, really quiet. It's the brushless step motor technology that we use, and they are high-end motors. They also have extremely low vibration values, so you could actually put a coin on top of the motor and it won't even bounce off. They're that smooth and quiet. This model here is the CN. It's similar to the CV, except this one will also give you just more volume capability, same safety features. It has also, like the CB3, I didn't mention that, but it has a container clamping system, so that wheel right there on the side, you used it to loosen and tighten the container. And if the container is not fully tightened, then the machine will not power on. It will show you on the display that it's not safe to operate. So you have to tighten that. There's a sensor back here to ensure not only that the container is perfectly centered, but that it also doesn't wiggle around, because you don't want the container or the blade touch the container wall at high speeds, especially if you're running solvents. That's not a good idea. But great machine. and kind of a middle of the range model. So that's the SEEC3 control panel on that CN model. So you can see that right here. That's the latest one that was introduced a year ago. And here you have also for that working area I mentioned earlier, you no longer have that slider on the side of the column. Here you have it electrically or electronically that you can select it right here with the H1 and H2. You just press those buttons and then it locks in these working area thresholds for you. Very nice design. This is the C control panel for our high-end model, that for the AE. I'll show you that in a second. That model here has more capabilities. Obviously, we show you the speed, the actual energy input in watts. You have also the Newton meters displayed down here as a torque value in actual Newton meters. We have the tip speed displayed up here on the top right. We also give you a temperature reading and a timer function. And then those two fields up here, the green ones, these are actually that the unit is safe to operate. One is the working area that's set, and the other one is the container clamping system. So if they are not green, then you cannot run the machine. So it's designed for ultimate safety. It gives you the ability down here on the bottom that you actually can look at the graphical display of the dispersion process, like actual trend lines for each of these values. It'll give you the ability just to change other things like program a recipe. So if you want to run one product all the time, and or you have a number of different products and you basically have cutoff values where you program, let's say, a certain temperature threshold or a maximum energy input or speed input, then that can all be set up and tied to a specific product or product name or number. And then you recall it at a later time, and then it automatically replicates the process all over again. What's great about this, it's really designed for R&D, but also with upscale capabilities in mind. So if you have a project you want to really go from lab all the way to manufacturing, then this particular model is excellent because it gives you the most flexibility for upscaling from lab to production. And that is the AE, that is our flagship model. Gives you all the same capabilities as I have mentioned. From the C technology point of view, has all the safety features, also fully modular, so it allows you to add on all these different attachments like all the other units. On the largest AE, we can go up to about 31 gallons of mill base, perfect for scale up. It allows you to also do what's called a net power calibration that basically allows you, before you start running with material, to just run the machine without product. And then it's, because it uses energy to operate itself, it would then factor those out. And then basically all the values that you see, like the amount of energy you're putting in or torque value, would only be related to your product and not to the machine input. It also, these cutoff values you can program. And not only can you run with a certain amount of speed, but you can also run the machine with a certain amount of energy. So what that means, instead of running it with 5,000 RPMs, I can say I want to run this particular batch with, let's say, 1,000 watts of energy. Then the machine will automatically adjust the speed depending on the state of my viscosity. So if my viscosity is increasing, my material gets thicker, and I maintain the 1,000 watts of energy, then my speed will automatically decrease. If the viscosity goes down during my dispersion process and I'm maintaining my energy, then my speed will increase because I'm still maintaining the 1,000 watts of energy, which is also really good because now it allows in an R&D application, for example, to precisely calculate the upscaling, the cost to manufacture a product, because you know exactly how much energy would you be using to make X amount of product in a certain amount of time. And that is possible with that C technology on the AE model. We also offer here the explosion-proof versions, a specific software package called WinDisp. We are working on a new version right now. It allows you to store and log all that data. And that's it. I mean, we are 30 minutes in. If you have any questions, please let us know. There's other presentations we have on YouTube and online, and we'll have other office hours set up for either milling or actually manufacturing great type of equipment. So if you're interested, let us know.
Yeah,
What's meant.
thanks, Andy. Great stuff. And also, we have and are recording this presentation. So immediately following this, you'll receive an automated marketing email with the link to this. Feel free to check that out later in the week or the next couple weeks. Feel free to forward it on to colleagues as well. We do have one question in here. If we do have a lot of time left. If you do have questions, please log them in the chat box in the bottom right-hand corner of your screen, and we'll get to them. First question here: why does milling have a lower tip speed than pre-dispersion?
That's a good question because I did not come up with the calculation. That's kind of like the conventional wisdom. But I believe is that basically they found that the sweet spot and also considering the wear of the rotor and the media, you don't have to run it at these exorbitantly high speeds because the turnout or the actual return of the processing would not add any additional value if you just add in a lot more energy. So I would say these are just ballpark numbers or recommendations. I wouldn't say this is the for every product. So I would say cautiously, if you have some applications that are not pigment related, where you feel like you get a better success rate with higher energy input or more rotor action, then that's possible. We just don't see it to be an advantage for most of the products and with our experience.
Great, thank
I
you.
hope that makes sense.
Yeah, very good. Yeah, because I suspect it's really dependent on what you're running and what types of products you're running. Backtracking to what type of disperser you need and what functionalities and other considerations like explosion proof, what other safety features are needed, things like that. So do you really start with the application, Andy, or what the product is, and then backtrack to in selecting a disperser with the right?
Yeah, so when we recommend a piece of equipment, we have like a questionnaire we go through just to talk about the type of application, the different viscosities, if there is any temperature concerns, is it solvent based or is it waterborne? So there is a number of questions that we ask to really identify the proper setup, and attachment
Great,
for the application.
great. And I love the fact that we do everything from pilot production all the way to full production.
Right, from lab to pilot. But usually, these dispersers or dispermets are really versatile, especially that modularity. And, they can be used for many, many different applications. We work with customers. Obviously, we come out of the coatings world. That's where we originate from. But we actually have customers now in the 3D print media world, a lot of battery development, hydrogen development for specific inks, that go into these markets. So we have a whole range of, we call them end-use markets where these formats are applicable. And we have a lot more technology. This presentation was just a quick overview, but we also have obviously dedicated vacuum systems, VL, LH, with integrated scraping that's used a lot in the battery development work. We have also the capabilities of adding a nitrogen purging valve on a closed loop system like the VL. Some customers like to have, inert gas flushed through. So we have all these options we can discuss with the customer.
Perfect. Yeah, if anyone has questions, now's your time. We have our expert here, Mr. Stummer. So please log them in and we'll get to them. Andy, are you getting, or I guess I should say, what are the frequent questions you get when a customer is looking to, get a unit?
Yeah, some of the basic question obviously comes always up is electricity. Where do I plug it in, and then how does it work in my lab? So natively, the machines run on 220, 230 volt, um, 50 hertz, but we have capability for North America that we made, so they will go in at 60 hertz, 220, 230, or we have also a 110, 115 volt option as well. 60 hertz, single phase. For the larger machines, like the CN, the larger CNs and the larger AEs, and all of the explosion-proof models, they require three-phase, and there we have options for 208 three-phase, and then all the way up to 480-volt three-phase. Natively, these machines operate at 400 volt, but we have ways that we can make these work on 208 or 480 or anything in between.
Okay, very good. Quiet group today. Questions, people? Anything?
The lab, and I want to talk a little bit about the lab in
Yeah.
Wallingford. So, we have this, we made this investment. We have a really nice labs space up in Connecticut at Big USA. And the reason we put it there was it's our sister company. They make high-end additives. We have a lot of customers that come in to us to not only review the equipment, to trial the equipment on their product, but then they come back and say, we have some questions on how to improve the formulation. What can we do better on our end? And then we tie in a chemist for that particular end-use market. Let's say you come from the battery world. We have a battery expert that can help you or us then to recommend certain additives to go into the formula to make it more stable or more efficient product. So these are all some of the key advantages that we offer through our lab up in Wallingford at Big USA. And we have a number of different dispermats up there. We have a horizontal bead mill. We have all the different attachments. I have a vacuum system. We have a vertical bead mill and APS. We also have basket mills, different screens for different media sizes. We also have measurement capability. So we can also, with a Horiba, we can look at particle size before and after. We can measure rheology, viscosity. We have color measurement technology. As you know, Dispermats is only one part of our whole product portfolio. We offer a lot of other things, color measurement, appearance measurement, physical test, anything to do with paint testing. We can be your number one source.
Yeah. So if someone has a product and they're interested in, coming up to Wallingford to run a trial, is that something they just work out directly with you? You schedule that? Is that right?
Yeah, that's correct. So how the process works is we have basically a few requirements. We will send you an incoming raw material form, basically that you fill out with all the products that you will be sending or bringing into our lab with the MSDS sheets. That is required by EHS to review the documents and then give us the green light or not to use the lab for a specific application. Once that all is set in stone, we then will schedule a lab visit. Usually they need about 2 weeks in between when you send in the documents to the point when you would be coming in. Then there is obviously safety training that's involved when you get there. It's about 10 minutes just to cover everything from what you can and cannot do in the lab. And then we will go right down to the pre-dispersing and milling. So
that's great.
and
And I know there's also training facilities. So if someone's interested in holding a seminar or a specific training, we can also accommodate for that.
Yes, that's correct. We have sometimes larger groups, bigger companies. They have a number of scientists that are new hires. They want to educate them or give them a really good broad baseline of the process, and we can organize something there as well. Bring people in, for a day, show them the equipment, show them the process, and then tie that in with like a seminar.
Perfect. And if at any time you have any questions or want to get in touch with Andy, you can hit reply to any of the marketing messages. It'll come to someone on my team, and we'll route them to Andy as well. Or if you have any other technical questions, also we can get that information for you.
If there is, if any of the in the audience, if anyone is interested in a more in-depth education on what we talked about today, and specifically about more the milling process, there is a number of videos on YouTube. This one will be uploaded as well, where you can actually see those. We can send you links, so you can just go on YouTube and search for Introduction into Dispersing and Milling. And there you'll find a whole range of different videos that have been uploaded from these seminars.
Yeah, and when you get that automated message, there's a link to our YouTube channel. So you can search. Andy has a whole bunch of stuff out there, like he said, so you can search and take a look and view what you need to. And if you have any questions, feel free to reach out as always. So there's no other questions here. Let's see. One more thing. And I'll put it in the comments. We do have a site. It's pigmentdispersers.com. It's more of an educational site. And I'm going to put it in the message here in the chat, so you can take a look there. More of an educational site, a lot of articles, a lot of frequently asked questions, things like that. Feel free to use that as a resource also.
And for product knowledge and information on all the different types of units we have, from lab, pilot, and manufacturing, you can go to this website.
Yeah, disperman.com. Thanks, Andy. You beat me to it.
It was just redone actually recently, so.
Excellent. So I think, let's see, one more question. Nope, I think that's it. So I think I'll wrap up here. Thanks everyone for attending. Thank you, Andy, for your expertise. We look forward to seeing you on future Bitgardner webinars. Stay tuned for additional invites, but also use the YouTube channel. Take a look at this recording and the 2 links in the chat for additional information. And as always, reach out and we'll connect you with the expert. Thank you, Andy, and thank you, everyone. Have a great rest of your day.
Thank you, everybody. I enjoyed doing the seminar today with you.
Yeah, good stuff, Andy. As always, thank you, sir.
Yeah, thank you.
See ya.
Bye. Thank you very much, guys.